Okay, now that we have touched on some solving yesterday, let's talk a little bit more about different ways to solve. So, in front of you, I have an equation. From yesterday, we know that in order to solve this equation, I need to make it equal to 0. So that means that I'm really solving 0 equals to 2x squared plus 3x plus 1. And now if you look at this, when you set something equals to 0, you're really saying, I want to know when y equals to 0, what does my x equals to? And if you think about it, if I were to graph this, I would get a graph that looks something like this. Well, where is my y equals to 0? Well, my y equals to 0 is this line right there. And when I have a y equals to 0, I'm looking at what is my x on this graph when it hits the y. So I'm really looking for these 2 points. And these 2 points are what we call the zeros, or the y-intercept. Right? So I technically do not have to do the x box to factor this out. If I have a calculator, I can just graph this equation on the calculator and then go right to finding the zeros for my analyzed graph. Or if the question is nice enough that it gives you the graph, for example, on your notes. When I need to solve x squared minus x minus 6 equals to 0, I graph it. Hey, look, here's my graph right there. And I'm looking for the x-intercept. Here's my x-intercept. Here's my x-intercept. I'm sorry, I should have fixed what I had said earlier. This is not the y-intercept. This is your x-intercept. So now if I'm looking at this, where is my x-intercept? It is at x equals negative 2. There's another x-intercept at x equals to 3. And you have just figured out the 2 x values when your y is equal to 0. And that is how you solve an equation by looking at a graph. If you're looking at, for example, your second example for part B, solve negative 2x squared minus 2 equals to 4x. Remember that I always want to make it equal to 0 first, so I have to subtract 4x from both sides, and I'm going to rewrite it in standard form. Negative 2x squared minus 4x minus 2 equals to 0. Now you can graph this equation and find your x-intercept and find your zeros. In this case, there's only one because the vertex is the only part of the graph that touches the x-axis. In this case, there's only one answer. X is equal to negative 1. Final answer. Okay, so that's one way to do it, solving by graphing. Or, if you're lucky enough, if you take a look at the second column, look at the first equation. 4x squared minus 31 equals to 49. Notice how there's only one variable in this entire equation. That means you can just solve it by isolating the x. To do that, I'm going to add 31 on both sides. That's going to give me 4x squared equals to 80. Getting the x by itself divided by 4. So x squared equals to 20. And in order to get rid of the square, I need to take the square root on both sides. Keep in mind, when I take a square root, I have a positive answer and a negative answer. So I have x equals to plus or minus square root of 20. And when I simplify square root of 20, I get x equals to, still plus or minus, 2 square root of 5. And that would be my two answers. You can either write it like this, or you can split it up and tell me that x is equals to positive 2 square root of 5, and x is equals to negative 2 square root of 5. Either way that's written is correct. Couple more things you might want to take a look at. If you look at this part right here, same thing, there's only one variable. That means I can solve for x like normal equation. Subtract 9 on both sides. 3x squared equals to negative 9. Divided by 3 on both sides. X squared equals to negative 3. Take a square root on both sides. X is equal to plus or minus square root of negative 3. Here's the problem. I can't have a square root of a negative number because a number multiplied by itself will always give me positive. Because of that, at this point, I'm going to say that's a no solution. Because I cannot take a square root of a negative number. Now you give it a try on the last one.